Bits per second. A bit is the smallest piece of digital information, just a 0 or a 1. So if a connection is 1 bit per second, that literally means one single 0 or 1 moves every second. That's really slower than watching paint dry in a slow motion. To send the letter A, which needs 8 bits, you have to wait 8 seconds. Yes, one character, 8 seconds. Now good luck for sending a text message. But here's why this matters. BPS, bits per second, is the foundation of every internet speed you know today. Kilobits, megabits, gigabits, they are all just bigger stacks of bits per second. Kilobits per second, kbps, the era of patience. 1 kilobit per second is equals to 1000 bits per second. kbps was the first real digital speed humans could use in everyday life. Think back to 2G and early mobile internet. Loading a web page, 5 to 10 seconds. Downloading an image, forever. Sending a photo, please wait, wait and wait and wait. 2G Edge dropped out around 384 kbps, which is barely enough to load modern Google's homepage. But it was revolutionary. It let early phones send emails, open simple sites, and remind us that images don't always load from the top. Sometimes they load from the middle for no reason. kbps worked so today's speed could sprint. Megabits per second, Mbps, the modern standard. 1 megabit per second is equals to 1 million bits per second. This is the unit you see on almost every home Wi-Fi or broadband plan today. When 3G arrived, speed jumped from a few hundred kbps to several Mbps. That created YouTube, social media, app stores, video calling, and mobile gaming. Everything we use today began at Mbps. But here's the part most people still don't know. ISPs, Internet Service Providers, measure internet in megabits, MB, megabits. Your computer measures downloads in megabytes, MB. 8 bit is equals to 1 byte. So listen carefully. If you buy 100 Mbps internet, your download will show 12.5 MB per second. 200 Mbps internet will show your download 25 MB per second. So here's the catch. Your Wi-Fi isn't slow. You're just reading the number differently. Gigabits per second, GBps, the fast lane. 1 gigabit per second is equals to 1 billion bits per second. This is where fiber internet, 5G and high performance networks live. At 1 Gbps, a full HD movie downloads in seconds. A 10 GB game downloads in under a minute. Cloud backups feel instant. 4K streaming needs less than 10% of this speed. Gamers, streamers, and professionals love this tier. 5G can reach 1 to 10 Gbps, meaning real time cloud gaming, 8K video calls, remote computing, AR VR without any lag. Real Gbps feels like your device isn't loading anymore, it's appearing. 1 Gbps is equals to 125 MB per second. So even massive files behave like tiny ones. Terabits per second, TBPS, the internet's skeleton. 1 terabit per second is equals to 1 trillion bits per second. You will not gonna find TBPS in any home. This is the speed used by data centers, undersea cables, internet backbone, intercompany transfers like Google, YouTube, Meta, national ISP infrastructure. Your home might have 100 Mbps, but the companies that power your content send data internally at multi-terabit speeds. At 1 Tbps, 125 GB moves every second. Millions of videos stream at once. You could download all 4K movies you have ever seen in a few seconds. Huge server clusters sync instantly. And here's the fun fact. Back then in 2022, researchers hit 1.88 Pbps, petabits per second, which is approximately equals to 1800 Tbps, basically downloading the whole internet simultaneously. Petabits per second, Pbps, the planet-wide scale. 1 terabit per second is equals to 1000 Tbps. This is the realm of global research network, experimental fiber optics, AI superclusters, and data teleportation prototypes. 1 Pbps is equals to 125 TB per second. This means send an entire Netflix catalog within 1 second. Back up all your YouTube's daily uploads less than a second. Replicate a company's entire cloud storage instant. In 2025, Japan recorded 1.02 Pbps over standard size fiber. It's not the future, it is already happening. At this level, the challenge isn't speed, it's stability and accuracy. Managing this much data is like trying to catch a waterfall using tweezers. Exabits per second, EBPS, beyond Earth level internet. 1 exabit per second is equals to 1000 Pbps, terabits per second. This speed does not exist yet. Not in Google, not in NASA, not in the world. But it's a goal for quantum communication, interplanetary internet, next gen AI clusters, and massive Earth simulation systems. 1 Abps is approximately equals to 125k terabytes per second. In 1 second, you could transmit every YouTube video ever made, every Google search ever logged, every document ever produced, every piece of human data instantly. At this speed, fiber cable becomes the bottleneck. We will need quantum lasers, satellite beams, or something not yet invented. Zetabits per second, ZBPS, the entire humanity level. 1 zetabit per second is equals to 1000 EBPS. We are so far from this speed that the global internet combined doesn't reach even 1% of 1 ZBPS. 1 Zbits per second is equals to approximately 125 million terabytes per second. With this, you could copy all human data in under a second, mirror every server on Earth instantly, connect all continents in the real time, and run a planetary AI systems like a unified brain. This level is theoretical, but it's the logical future for global connectivity. Then comes yotabits per second, YBPS, beyond imagination. 1 yotabit per second is equals to 1000 ZBPS, which is equals to 1 septillion bits per second. At this speed, we leave technology and enter science fiction. 1 yotabit per second means downloading the entire internet in a fraction of seconds. Zero latency or to Mars communication. AI models syncing worldwide instantly, and data transfer faster than human neurons fire. This is the kind of speed future quantum networks might handle, transferring not just data but knowledge itself. Now, thanks for watching this video. Make sure you subscribe to this channel. Deep Simple.